Welcome to my YouTube channel. This is my first tutorial video, and today I'm going to demonstrate how to convert a JSON object to a Swift object through JSON Decoder. We all know what is a JSON object. It is actually a string which is structured in such a way, in a key value pair manner. So this is a simple JSON string. This is not very useful, but it will show us how to do things. This has this curly braces block and has a key name and a value, which is JSON. And to decode this, we will use this class JSON Decoder, which is inside the foundation. We have imported the foundation. Let's make an object of this JSON Decoder. JSON Decoder. It's very simple initializer. So a JSON decoder decodes a JSON data to a Swift object, and if we see, and it returns a Swift object. So if we see what a JSON decoder decode method has, it takes this type, which is a type that implements a decodable protocol, and it converts from the data to a Swift object, and it throws a decodable object. So what is a decodable protocol object means? That means anything that we have structures and classes or enumeration that can implement a decodable protocol. So we will use this type of any such custom objects and send a data. So we have to have this type to provide in this decode method. Okay, so we will use a struct. We can use a class or anything, but we will use struct. It's very fast and very sleek. So let's make a stock. Let's call it name. And implementing decodable protocol actually just only needs this mention. It's decodable. Now, if we see that what a decodable has only an initializer. It doesn't have anything else. It has only an initializer, and we can or cannot use. We may or may not use this initializer. It is optional. So this is a structure, we will have these properties, and we have this property. Let's say we have this key called name, and we will call this property as name as well, and it will have a string, as we have seen here. This is a string, so it will have a string, and this is actually everything that you need to do to convert this JSON object to this Swift object. We will provide this name type, which is this is a name type, and we need to provide the data. So how can we make data from this string? We will have JSON data, and data has an initializer, a very convenient initializer that takes a UTF-8 string. So we will provide JSON string dot UTF-8. Yeah, that's actually everything that needs to do. So we'll provide JSON data, and we will store this JSON decoded value to an object. Let's say we will call it decoded, and as this decode method throws, it has to use try. Okay, so we'll just provide try here, and this is everything. This is actually everything. If we print this decoded, this is if we place dot, we have this name. We have found this is actually the type of name object. So if we print name, we run this playground, and we see it prints JSON, which is this name. That means it actually could map this JSON string. But if we want to change something, let's say we don't give it name because it doesn't actually feels right. Okay, so we will give it call it name string, and we will print name string as well. So how will it work? You know, if we run this, we have this nil. Why do we have nil? Because JSON decoder, what it does, it actually maps this key to the same named variable over this in this structure. If it finds and place the value of this key to this variable. Okay, so we don't have the same name here. So what can we do to make this happen? We should be able to do these things, right? So we know this decodable protocol has this initializer from decoder, and this will be handy in here. So a decoder initializer will provide the place that it takes, but we cannot directly like say name string equals decoder dot decode, because it doesn't have anything like decode. A decoder gives us a container. You see, a container. So a container, what is a container? A container is actually, this curly braces is a container. A container is something that has a block, like in JSON's object we have this block, right? So this is a container. So this decoder will give us this container that contains the key value pair over here, right? And the container will give us this value, right? Okay, but so we will have this value variable container, and this will decode the container. This will the decoder will give us the container and stored over here, and we will use the container to store name string equals container dot value dot decode, right? So the container will give us, but to use this container we have to, you know, the decoder throws, so yeah, try, and we have to give this coding key protocol. So what is a coding key protocol? A coding key protocol, if we, you know, look at this coding key protocol, this protocol have these variables, string value and init value, and it has two initializers, right? Two optional initializers. Okay, so these are get, this cannot be directly set. So as we have already said, that a protocol can be implemented through by a structure class or an enumeration. So in this particular case, for decodable case, the enumeration is the best solution to pass these types, right? So we will use this enumeration, and we will call this coding, as it is calling for a coding key, so we will say it name keys enumeration, because it might have multiple values as such as age, which is not convenient for a name object. We will leave it that, but you know, you understand that this might take multiple variables, right? So, and we will implement this coding key protocol. Okay, it's very convenient, and we will have this there will be a case that actually matches, that actually could match this you know, name string and this name. So we will have this case called name string, and we will assign this key here in this case, such as the name, right? But to have this assignment, we need to say this enumeration will have this explicit string protocol implemented in here. So if we have explicit string, it has an internal string. A case has an enumeration case has an internal raw value, which is a string. But to explicitly say this is the name of the string, we have to implement this string protocol, right? Okay, so here is how we will say keyed by, and what we have this protocol coding key protocol type, name keys dot type is self. So that's it. We have our container. So how do we use this container? We container dot decode. See, we have this method, this very simple method that will decode the string type. We don't have type. We will say self to this name string. And for key, which is the key, what is the key? We have key decoding container. names.key. Now we have this enumeration keys, and this is the key. This is the case key, which will provide the key. This is name. So we will say name string. Yeah. So this is very simple. We have the name string key, which will provide the key here to this method, and we have this type. We have already seen this JSON decoder, how this makes a type and from data. But this is a little simple. We have this because we need to try, because this throws, and that's it. That's it. Now if we run this, we will see that we have gained our previous name value. We could parse this name value again. This running playground is running. Yeah, we have this. So this is Zahid Hassan. So this is very simple. We need a structure or a class that implements the decodable protocol to use this JSON in this JSON decoder, and from initializer we need this coding key protocol implementing structs or enumerations. You can use a struct. I have already tried this. Structs works, okay, but you can experiment over this. So this is a very simple JSON, but if we need to use of more complex JSONs, like let's say another JSON string, I will use a more practical example, because I have already used this pagination object, which pagination object we always need this pagination objects when you take response from APIs. It might be paginated response, so we have this paginated object. So let's make a paginated object, JSON object, skeleton, right? We have data. We have a JSON object which might use a meta object, which will contain this pagination object. Pagination. Yeah. So a pagination itself is an object which will have multiple key value pairs. Let's say we have this count per page, object per page is 10. So yeah, very simple. We have this meta data object which has a pagination object which has a key value pair called count. What we have to see here, that this is a container. This is the original container of the JSON object, and this is also a container which is keyed by the meta. We call it a nested container, a container inside a container, which is a nested container that is keyed by this meta key. And the pagination is also a container that contains this value. We actually have this value count value over here, but we need to go through these containers. Like first, this is called a container, and this is the nested container, meta container, and this is a pagination container, right? This actually happens all the time, and this is why I am making this tutorial video, because I have struggled to parse this kind of JSONs all the time. Initially, what we can do is, see, we have provided this string type, right? But we might use a different thing here. Let's say we make this a name, an object, say first name, first, first has this Zahid, and yeah, last has Hassan. So we have seen this is a nested container. This is a nested object, right? This is a nested object inside a name object, right? A name key, and this is a nested object. So what we can do, we don't have this name structure, we don't have this name string inside, but we have this name has an object. Okay, so sometimes we might have an object inside a key, instead of a value, right? So we can do two things. We can make another structure we will call it name splitted, and it will provide a decodable protocol. We will have this variable first string, and we will have last string. Okay, so this is actually quite helpful. You see, this name string, which is a name string, it doesn't have to be a string now, because this is not a string, name string. This is an object. This is a name splitted object. Name splitted object, right? A name splitted object will be now will be name. Let's say we don't call it name string. We call it name object. We'll copy name object. Yeah. And it doesn't conform to string protocol. It will conform to name splitted type, right? And it will do it will do just the same, because it oh yeah, this name object key. So this is actually pretty amazing, because now we don't have this you know, what we can say is a very name object dot first. Okay, so this is pretty interesting, because we don't have this, you know, string type or integer type like these types. We have our own type, this own structure, and we can, you know, nest it inside this object. But if we have these kind of nested 3-layer or 4-layer type of nested things, we will need to make these structures, a lot of structures, like name and a name splitted. And if we have this anything like, you know, surname, and we have this this will also an object, right? So what we should do is we need to make another structure for this surname. So there will be many more structures and many more classes to be written. So there is a simple solution for that if we don't want to write this kind of. You see, this meta container only has, this meta object only has one value. This is a pagination, and it is also a structure which only has a value. So the important thing is count. We need to fetch this count, not this meta pagination and all. See how we should have decoded dot name object dot first. This will make a string of calling, right? So what we should do is make a struct, and we will call it nested JSON, which will implement a decodable protocol, and we will have nested JSON, and we have the decodable protocol. Yeah, everything is set. We now have to declare the variable, let's say count. This is an integer. It's pretty simple. How do we fetch this count from inside these layers, right? Okay, so as we have already saying that this can be implemented, this enums and initializers. So let's make an enum. What we can say, this is the main container, the main container enumeration. So we will call it coding keys, and it will implement coding key protocol. Okay, coding key protocol, and we will have this first coding key object. What do we have this key? This key is called meta, so we'll call this meta, right? The case is meta, we call it meta. It's absolutely fine. And we will have this initializer from decoder. We will call it let container. The main container is try decoder dot container, you know, keyed by, we will say coding keys dot self. Yeah, we have our container, but our container has another container called pagination. It is a nested container, right? So we don't have this count, so we cannot say, let's say count equals container dot decode. Yeah, so integer type, because this meta is not integer type, this meta is a nested type, right? So we will not call this method here. What we need is we should traverse through these blocks or containers, from this container to this container to this container, and then we will decode the original value. So how to traverse to nested containers? Let's make another container. Let's make another container which is called pagination container, right? We have this pagination container here. So a pagination container will also decoder, not the decoder, container has a pagination container. So we have to remember, we have to traverse through these containers. We have this original container which is a meta container, and the meta will have this container which is a pagination container. So yeah, container.nested container is a very useful method, nested container, which will take this coding key, another coding key protocol, and another key, right? So we can always so we can always pass this meta over here. But the coding key protocol, what is a coding key protocol? We need another thing that will map this meta inside this pagination container, right? Sorry, we will call it meta container because this container is called the meta container. I'm sorry. So we'll call it a meta container. Okay. So what a meta container contains, a meta container is also an enumeration, just like an enumeration container, a coding key container. A coding key has this, and a meta is also the just the same type of thing, but another level deeper. So we will have another level deeper. Go another level deeper. We will call its meta keys because it has the meta keys, pagination, meta key, pagination, and we'll call the coding key, yeah, protocol. And what we have, meta key, we have a key called pagination, right? So we will call this pagination. Okay, so we have this coding key protocol. We will also have meta keys. This cannot be directly called meta keys, meta keys, because it will not find the meta keys. How will you access it? Is coding keys dot meta keys, yeah, dot self. So this is how we pass this meta key enumeration type to this, and we have this key, meta. But meta have this pagination key, so we will dig another level deeper. We will make pagination keys, coding key, and we will have this count value, right? So we will need a pagination container which is inside the meta container dot nested container, because we have this pagination inside the meta container, right? So meta container dot nested container, and the coding keys by coding keys dot meta keys dot pagination keys dot self. Yeah, we have this type. And what is the key? The key is pagination. We have to remember the key is this pagination key can be referred by the pagination key. What is the pagination key? This block is represented by this key. This block is represented by this key. So this block, this enumeration is represented by this key. We have to remember this. Okay, so this is pretty cool. And now we have count equals pagination key container dot decode, yeah, it's in the integer dot self, and we have this count here. And if we run this, we will have everything. Yeah, we will have let another JSON. Oh no, we don't need to initialize this. We will say let data, data is data, initialize another JSON string dot utf8, and we will have this another decoded equals, we will say JSON decoder dot decode, the decodable protocol will be nested JSON, right? So yeah, nested JSON, and the data will be data. Yeah, but it will need a try because it will throw. And if we print, if we print this another decoded dot count, we will find, oh sorry, it also needs to try this try. Another, oh yeah, I'm very, so now we have this optional, now we'll have this option, this optional count, which is this. So congratulations, we have nested, we have mapped the nested containers and nested values inside a value. So now if we just need to another decoded dot count, we don't need to say that, let's say another decoded dot meta dot pagination dot count, we will say just another decoded dot count. But if we dug another level deeper, let's say links, and what will we have? We have another object that will have two values, previous, which will have a string, let's say anything, it will have a link, and we will have next. We should this is next link, and yeah, don't make it garbage. This is previous link. Okay, so if we dug another level deeper, what will you do? We will make another level of enumeration, links keys, right? And we will provide this coding keys, the previous, previous and case next, right? So these link keys, how will we refer to this link keys? The key is links, so we will need this case called links. Okay, coding keys, no sorry, coding key. Okay, so we have this code link keys enumeration, which will be pointed by the case, the key links. We have this key links. This will make another object which will have this previous and next. So we have count, but we don't still have this links. We cannot direct from pagination container. We will make another container, which is a links container. A links container is try pagination container dot nested container, nested container, which will have coding keys dot meta keys dot pagination keys dot link keys, right? We make this, we can make this, I'm saying we can make this outside, of course, but nested is pretty convenient and pretty easy to see how this is going to represent this structure, right? We can always make this enumeration visible outside of this enumeration, so we can make this out of this block here. Okay, but let's make this clear. So what we have links key, right? And now if we want to have this previous link, which is a string, and another next link, which is also a string, this should not be forcefully optional. I am using optional because there might be a previous link or might not be a previous or next link. This is actually a valid pagination object. I have used this. You will find, if you see a lots of APIs, you will see you will find this kind of structures in a pagination object. Okay, we will have next and previous links. So we will provide a value to the previous link through the links container. Try links container, yeah, we have links container dot decode, which is string type. Okay, a string dot self, and what we have the key, we have the previous key. So it's very simple. Next link, try links container decode self. Next, yeah. and we here, if we print this, another print another decoded dot previous links, if we run this, you see, yeah, this is the previous link. So we have successfully decoded a very nested JSON into this sweet swift nested object. The code might be looking very ugly or something, but this is really convenient. But just not to make this kind of structure, this kind lots of structures, a meta structure, a pagination structure, a link structure, we might use four structures actually, including this nested JSON structure, four structs to map this meta if we would be using this kind of implementation, right? But we can use this method, container method, and this enumeration coding key method to make this only one struct. This is very convenient. So this is all I know for today. Thank you very much for being for this long, and please support me in this YouTube channel. Thank you.